In this video, we are going to look at writing ionic equations. Okay, please don't confuse your ionic equation with full chemical equation. Okay, ionic equation, what does it mean? It involves ions in an aqueous solution. Okay, it let us know which species in the reaction reacted, which are the spectator ions that does not take part. Okay, so these spectators ions that they don't take part, they appear on both sides of the equation. Okay, so write the full equation with the state symbol, split the aqueous compounds. Okay, recall your solubility table. Spa, sodium, potassium, ammonium are all soluble, aqueous. Nitrates are all soluble. Chlorides are all soluble except silver lead chloride. Sulfates are all soluble except barium calcium lead sulfate. All carbonates are insoluble, okay, except the spa. Carbonates, these are rocks, please remember. Okay, and then lead 2 compounds are insoluble, and your oxides, hydroxides are insoluble except the spa. Oxides, hydroxides are bases. Okay, solid liquid gas cannot be split, okay, because they are not ions. Okay, so we can only split the aqueous. Okay, and then cancel the spectator ions that appear on both sides of the equation. Rewrite the equation including state symbol. So moving forward, you know, when they say write ionic equation, take as you know, you have to write the state symbol. Okay, so example over here, sodium hydroxide plus hydrochloric acid give you sodium chloride plus water. Sodium hydroxide aqueous, hydrochloric acid aqueous give you sodium chloride plus water. Right, same thing, do this swap partner thing, and you should know sodium hydroxide spa aqueous, acid aqueous, spa sodium chloride aqueous, water liquid. Okay, split the aqueous compounds into the ions. So I split the NaOH, HCl, NaCl, and then H2O. Because it's not aqueous, leave it. You cannot split solid liquid gas. Cancel the spectator ions, right? Cancel your Na because it appears on both sides of the equation. It's just floating around. It is not taking part in the reaction. My Cl, left side also have, right side also have. So same thing, Cl is not taking part in the reaction. So this is H2O. H plus plus OH minus form H2O. This is your ionic equation. Okay, using the same example, let's try 2 examples over here. Okay, the first one, copper sulfate. Okay, copper sulfate. Sulfates, please remember, barium calcium lead sulfate insoluble, so this is aqueous. Sodium hydroxide is aqueous. Copper 2 hydroxide is solid. How do you get copper 2 hydroxide? Take the metal, keep the sodium, so copper partner the OH, copper 2 hydroxide, sodium partner the sulfate. Okay, sodium, potassium, aqueous. Okay, copper 2 hydroxide, why is it solid? Because oxides, hydroxides are bases, they are insoluble. Okay, so after you do this, split it into the ion. So Cu2 plus, SO4 2 minus, Na plus, OH minus, CuOH2, this is solid, cannot split, leave it. Na plus, SO4 2 minus. Okay, then cancel your spectator ions, ions that appear on both sides. I have SO4 2 minus, I have Na plus. Right, and then rewrite your equation. Your equation will be whatever that's left behind. Cu2 plus equals OH minus 2 OH minus, right? Because if you balance out your equation, you have 2 sodium hydroxide on equals give you Cu OH2 solid. Okay, same idea, magnesium carbonate, sulfuric acid, split the aqueous. So I can cancel my sulfate, cancel my sulfate. My magnesium, this is solid. You know it don't split it into Mg2+. So this one you cannot split. Your magnesium, this part is Mg2+. That's left. Right? H+, 2H+ is left here. Okay, and then you get your CO2, H2O. So your overall equation will be this. NgCO3 solid plus 2H plus equals, give you Mg2 plus equals plus CO2 gas plus H2O. So same thing, once you split the aqueous, take as you know, you have to write in all your state symbols. Okay, and please remember, balance up your equation.